So here are a few basics. First of all, solar hot water is not a new technology. Today's systems they're not unlike those installed 40 years ago when Jimmy Carter made them popular after installing a system in the White House in 1979. The collector design hasn't changed much. They're still about 80% efficient as they were in 1979. Solar electric panels are only about 20% efficient, which gives you an idea of the relative efficiency. And the solar thermal industry is strong worldwide, especially in Europe and Asia. And the systems are robust. We often come across systems that were installed in the 80s when Jimmy Carter made it popular, and they're still operating. So these two little pie charts at the bottom, most owners don't know how much they spend on domestic hot water. And though there's been a lot of work reducing space heating loads, not so much with domestic hot water. So for the average home, domestic hot water might be 23% of energy use. But with super insulated net zero homes where space heating load is low, domestic hot water becomes the largest load, actually, close to 50%. So in the Northeast, where we have less solar radiation in the winter, it makes financial sense to build systems that supply year-round domestic hot water rather than space heating. And this little graph here, because solar energy is 100% renewable and free, solar hot water systems offer the least expensive option to heat hot water. Here's a graph over 20 years of solar versus other fuels. Okay, so looking at how solar hot water works, we're all familiar with these two scenarios. Car dashboard absorbing the sun's radiation, heating up super hot, even in the winter, and the transfer of heat to water in a garden hose that's been sitting in the sun. These are basically the basic principles in a solar hot water system. There are two common types of solar thermal collectors. They both work by absorbing the sun's radiation via an absorber plate, like the car dashboard, and transferring the heat to a fluid in a pipe, like the garden hose. So you can see in these diagrams the large absorber plate in the flat plate collector and the smaller individual absorber plates in each of the evacuated tubes. So flat plate collectors have proven their durability over the past 50 years. Evacuated tubes are a newer design, a bit more expensive, but because of the vacuum tube, they're more efficient in colder weather. Here's a diagram of a typical single tank residential system. Two to three collectors on the roof, piped to an 80-gallon solar storage tank. The line set piping creates a closed loop containing a water glycol mix pumped through the collectors and the heat exchanger in the tank. When the tank is full or hot, or when the sun is not available, the system turns off and the fluid drains into the drain back tank here and here. This non-pressurized drain back design eliminates the possibility of freezing or overheating, which was an issue with older pressurized systems. You can see the controller mounted on the tank and the mixing valve required by code, since the tank is allowed to get hotter than normal in order to store more energy. For periods of less sun, mostly in the wintertime, the system can rely on a conventional backup system, either an integral electric element or by adding a heat exchange loop from an existing boiler like Lisa's system. This acts like any indirect hot water tank. We also install systems that preheat conventional water heaters. So in this case, cold water from the street is routed through the solar tank where it's preheated before delivery to the conventional tank. The conventional tank is thus used only to add heat if necessary, mainly in the wintertime. The photo shows preheat of a conventional gas-fired tank. Any type of water heater can be preheated, including tankless on-demand systems. Maintenance for solar hot water systems is really minimal. The solar fluid should be checked every 5 to 7 years, and the solar pump is the only moving part and may need to be changed once or twice during the 20+ year life of the system. A new pump is inexpensive and can be installed by any plumber. Manufacturer warranties are strong and the other system components are robust, all built to last 20 to 25 years without need of replacement.